Welcome everyone. Today we have our another new episode and we will discuss on advance in Nikola Tesla technology. We will discuss on radio. First, I would like to give chance Mr. David Smith.
Well, Sharif, thank you. Let me make sure I'm unmuted. Sharif, thank you so much for letting me be on the program today. The Nikola Tesla had invented many, many different things, and radio was one of his interesting ones that he began to work with this with his other experiments and things in energy and transmission, like his Tesla coils and others. And the what was interesting is that the invention of the radio communication was really preceded by decades and decades of independent discoveries that looked at things like radio waves, propagation of waves, and quite a few bits of it. Uh, it was kind of interesting because both Tesla and Marconi uh, both created radio technologies around the different times, and what and how they were pulled together. And many, many inventors tried to build radio systems on a lot of different approaches and other ideas. But it was really the fact that it began to come out, and you saw people like the discovery of electromagnetic waves, which is the underpinning of the radios, was discovered by uh, Rudolf Hertz back in 1880, which Hertz is still used to talk about those frequencies and things to this day and things. But you began to put the pieces together and do it. Uh, you saw Marconi doing stuff, you saw Tesla, you saw a Canadian inventor who became the first person to send audio by means of electromagnetic waves and things. It's going back quite a while, and the different patents and things with it. Where Tesla began his research in this area was when he was working on some of the phone and other type of inventions around that time early in his career. So Tesla began his research into high frequency electricity in the early 1990s, and he was well aware of Hertz's experiments with electromagnetic waves, and he thought that they applied to radio waves, but they probably only traveled in a straight line. And so he began to focus his focus on radio of building a conductive based system, and began to use it. He used it for power, he used it for radio, and he thought he could build a conduction based worldwide wireless system that would use the earth itself as part of this. And he began to build it into other types of systems very, very early. And he applied a lot of it in different areas with some of his experiments with X-ray and other things as well. That was part of what was used here and part of how it was beginning to use uh, in many different ways. And he worked with many inventors of the time to work and pull that out. And he had so much of his early life and things were focused on waves, power transmission, from his inventions of the AC electrical system, the Tesla coil, uh, his shadow box, his and others. It just really went to show that he was a very prolific inventor, and these are things which he could apply really well to a lot of different areas as he worked across wave technology. And he really discovered that he could transmit radio waves that could resonate at the same frequency as what he was doing with his power. And when a coils turn to different frequencies, he created what he called a magnifier, which is part of how the radios began to get much longer range. And Tesla filed his own basic radio patent application in 1897, which was granted in 1900. And so that was actually earlier than when Marconi filed his. And you begin to see it, but no patent safe, as Tesla's career illustrated. And the Marconi approach ended up overcoming the Tesla one, and his patent was actually overturned in 1904. And the patent office ended up giving the Marconi the patent for the invention of the radio. And you see that going, but he was in lawsuits and other things with Marconi during that early time of history around radio. But the two of them did invention work and file patents at really very close similar times in regard to the radio technology. So Dr. Sharif, this is, I think, where I can stop right now.
Thank you. Mr. Rob.
Well, good morning. So radio technology, as David said, Marconi was the one that really got the credit for the radio. Tesla was first, and in theory, his technology was better. It had greater range. The problem was Tesla's workshop burned down at an inopportune time. I think there was some speculation at the time as that perhaps that workshop being burned down wasn't accidental, but the Tesla was often surrounded with suspicious accidents that seemed to derail whatever it was he was doing. Much of the suspicion was focused on Edison, who hated him, and I think Tesla hated Edison as well. So his radio technology didn't really go all that far in terms of radio. Where it did advance was in areas like magnetic resonance, and it's believed that his work was the foundation for things like the MRI machine. And on the radio side, he did have the first operational drone, and he used his technology to operate the drone. So the showcased how radio technology could be used to run other things, and probably is the foundation for much of our drone, at least in terms of theory, much of our drone technology today, which of course is for the most part radio operated, moving to autonomous. No connection, at least at this moment, between Tesla and autonomous machines. That's a whole different thread. But his radio capability kind of became the foundation for magnetic resonance stuff. His work worked into the precursor to the X-ray machine. Can't recall the name of the damn thing, but it was a much better name than X-ray. And in the end, he has had an impact. Sadly, of course, he died poorly, broke, and in very poor health. But his potential, of course, was and is still heralded from the things he could have done and the things that his technology eventually accomplished. Of course, the big thing that he wanted to do was broadcast power, and the Tesla coil at a scale that was almost unbelievable in New York. Was kind of a showcase of both the threat and potential of wireless power, because those huge lightning machines were not something you'd want to stand close to if you were grounded. But the concept, of course, is now expanding in terms of broadcast power, as we spoke earlier, with a number of companies looking at being able to broadcast power. So, and you might argue that once you're into broadcast something and it's a waveform, then using that same waveform technology to convey power to someplace else is consistent with that work as well. And so broadcast power, which is beginning to advance, and I'm not talking about inductive power, which is very different. But that could also be tied back to Tesla, because that uses magnetic resonance, much like the original work that Tesla did in that particular field. So in many ways, I think Tesla probably has a bigger impact on the things that don't really have that much to do with radio, but are adjunct to it: drones, broadcast power, and other things that use magnetic resonance as a way to convey information or energy. So certainly an interesting life, an interesting guy, and now I'll pass the baton over to whoever else.
Thank you. We have our
Yeah, yeah, hello.
Shovik. What you want to discuss
Yeah,
about
hi.
Nikola Tesla, and if you want to share a few of your experience from that, that will be helpful
Surely,
for
sure.
our audience.
Surely, Sharif, yeah, thanks. So, to specifically start with, means I will like to go back to the early stages of the radio technology, like when Nikola Tesla was just working on making the technology. In an early demonstration, he had showed that what I have learned that means a boat was was in a pond which was controlled by a robot there with a remote there. So at that stage, people wasn't aware of this remote technology, so they thought it as of a miracle or something like that. But Tesla had known that and had later stated that it was controlled by a remote, and this can be said as the early stages of this radio technologies, like yeah, remote transmission of waves and all this. So this is the very start of the radio technologies, and after that means to transmit this what we say data remotely, there had been a lot of modifications to these technologies, and specifically another thing like Marconi is regarded as the inventor of radio, but there was also news that basically at that time Tesla was also researching on this and might have invented this radio technology before Marconi, but due to some patent issues, it was given to Marconi there, as far I know. And afterwards, when some modifications had been made to this technology, like to transfer data remotely, you have to make some encryptions and all these things. And all this has been uh, used afterwards in making things like typewriters and radios and walkie-talkies and all these things, which was used at those days like that. And even radio was a very common thing almost 30 years ago from now, before the coming of the internet. So the radio has a lot of usage all over through the last century. So and Nikola Tesla can be said as the main mind behind this technology. And besides this, Tesla has also been working on some free energy. Like he was looking to provide electricity to the whole world just through the what we say the through the outer layer of the atmosphere. He was thinking to provide free energy to the whole world and working on that also. He had made a Tesla tower, what we know as in somewhere like Colorado or somewhere there. And at that time, he was almost done with that, or may have developed that also. There were speculations that it has been developed, but due to some restrictions, it cannot be provided commercially there. And we all know about the Tesla's contribution in the AC current and his large AC generating factory there in the Niagara Falls in US. That was another major contribution by Nikola Tesla. Though this had been abolished currently. The yeah, the factory in Niagara Falls, but that was one of the very first factories that had produced AC current and in a large scale. That had been a real provided real competition to Edison there with Edison's direct current. So, and besides also these things, Tesla has also lots of contributions in other techs also. It's basically he was working on wireless technologies and had worked on several other devices which worked on wireless technologies in specifically in Colorado. And afterwards he had made a lot of contribution in this field, in the wireless field, and like things like this radio transmission and all this. Yeah, thanks. Yeah, back to you.
Thank you. Professor David Smith. Thank you.
Yeah, thank
Professor
you.
David Smith.
Sri, thank you once again. As Rob said and as we've said, Tesla was a proficient inventor and really put more into it than you thought. The conflict between him and Marconi was a real interesting one, where Tesla took the time to really develop uh, more powerful waves, as both Rob and I talked about, and others. And so Tesla really was focusing mostly on the technology and how it was done, uh, where Marconi's real contributions are more commercial and beginning to take the idea and put it in others, where Tesla's was mostly looking at the technology and the theoretical approaches to that, and more around the physics and the mathematics that went into it. Uh, but the big place where Marconi's uh, got the start on the radio side is actually was the transmitting two ships. He formed a wireless telegraph business for the British and did the very first transatlantic transmission of that as well. So you saw that going back and forth. And however, the patent battles between Tesla and Marconi went on for years and years and years, uh, and went forward. What was interesting is Marconi died in 1937 and Tesla in 1943. But 6 months after Tesla died, the U.S. Supreme Court ruled that all of Marconi's radio patents were invalid and awarded the patents for the radio back to Tesla. So originally, Tesla filed, Marconi protested, and the patents were awarded to him. And then 64 years later, they were actually back and awarded back to Tesla. And really, you can see it and see how it applies across so many different places. But really, radio or wireless was strictly a telegraph media into the first vacuum tubes were invented. And then that is when you began to see the type of radio transmission with audio and things like we see today. So it's a very interesting process there of the intellectual property on this, from Tesla's first patent, Marconi overturning it. Then, after both of them had died, the US Supreme Court overturning Marconi's patents and giving them back to Tesla. So it just shows you that the innovation world is really tough to work in and succeed in. But commercialization is one of the most important things. And Marconi on the radio side was focused more on commercialization, where Tesla was focused more on the principles and the engineering, the theory behind radio. So, Dr. Sharif, I hope this helps you as we go there.
Sure, Professor Rob.
Hey, I guess I'm up next. No, I don't really have that much more to add other than just filling space. Because it was the Marconi technology that was advanced. At least on the radio side. Even though the Tesla was awarded the patents sometime later, he kind of gets. It's kind of the sad story of Tesla's life, though. Much of his impact and benefit occurred after his death, and he didn't really get that much credit for it while he was alive. Certainly not towards the end of his life. Kind of a showcase of someone that was ridiculed and treated very poorly up until the end. And then right at the end, a couple people did step in and really try to help him. But given his contribution to the world, the way the world treated him was pretty poor. But in any case, at least from my perspective, I've kind of covered as much of this as I know to cover. So unless Dr. Sharif has a specific question, I don't really have that much more to add. Dr. Sharif, do you have something a specific question you want me to address?
Professor Rob, as
Yeah.
World Talent Economy, Rob, can you hear me?
Yeah, I can hear that. Can you hear me part, but everything between
You froze.
Mr. Rob,
parts,
can you
you
hear
just
me?
froze up. I can hear you now.
Okay, can you hear me now?
I can hear you now.
Okay, Mr. Rob, as we are uplifting different technology of Nikola Tesla, what do
Yeah.
you think? Like in USA, specifically different corporations, though they are engaged with the uplifting of Nikola Tesla different technology, or is there any new innovations happening right now, especially in Silicon Valley?
Well, we mentioned on a prior session before I wandered off to Chicago that there's an aggressive effort to work on to use broadcast power right now in the valley. The mostly to power sensors as we talk about building the metaverse and creating virtual twins and keeping those virtual twins synced with their real life counterparts. That requires a massive number of sensors, and pulling power to all those sensors not only would be very costly, it'd be very wasteful. And so going to a broadcast power methodology tends to work much better. Then you can just attach the sensor, which is already communicating wirelessly with its host, and not have to pull power to it. And so you're not wasting the copper. You're not putting more plastics into the environment that we use for insulation on the copper. And you're cutting down on the cost of installing the sensors. And we were talking about sensors that we're going to be numbering in millions, if not trillions. Getting rid of the wiring reduces the overall installation costs substantially and increases the speed of the rollout, because all you have to do is build the sensors, then have somebody affix them to the different places that they need to be affixed, and then logically connect them to the host, and you've got a sensor network. But if you have to wire each one of those sensors, then an electrician has to come out. They have to pull the wire, even a low voltage wire. They still have to pull the wire to the sensors. They have to shield that wire so it isn't broken, and assure the wire will hold up as long as the sensor does. And then of course, when you replace a sensor, it's not just simply as yanking it and replacing it. You have to decouple it from the electrical system when you do so, which means you generally have to have, in a commercial situation, you generally have to have an electrician do that. Where if you're just attaching sensors, you just tell somebody where to do the sensors, and you can use hourly labor to do it. So it's far less costly to deploy the sensor networks we need. And as we move to things like autonomous machines, autonomous cars, and start really using the metaverse as it's initially intended as a commercial effort to assist with advancement, maintenance, and securing sites, then these massive number of sensors are critical for that effort, and being able to deliver the power to them wirelessly is critical to making that both feasible in terms of cost and feasible in terms of labor. So that's probably the biggest impact of the Tesla technology. I should point out magnetic resonance certainly has had an impact prior. We certainly in the medical field of MRI machines, but that's more historical than current. And magnetic resonance used for inductive charging, that was more of an effort, I'd say, about a decade ago. It doesn't feel like we're even using magnetic resonance as much as we were 10 years ago. So that appears to be in decline as well, with the possible exception of automotive, which is looking pretty hard at magnetic resonance at the moment as a way to power electric cars and reduce the size and capacity of the batteries, which is the electric cars' Achilles heel. And if we can figure out a way to inexpensively put magnetic resonance into roads, and particularly into parking spaces, we could remove much of the range anxiety problems that current electric cars have. That's at least that's from my perspective. That's where I see much of his efforts right now is in power, both forms, broadcast and resonance, but resonance mostly focused on automobiles, and broadcast power mostly focused on sensors. And I'll pass the baton. Sharif, you look like you're frozen again.
Do you
Hello.
believe that now around the we are doing developing
Hello.
Sharif, we really need to get you a better internet connection. About 1 word out of 5 is making it through, and we can't make out what you're saying. I think you're up now because we just lost Sharif.
Yeah.
If you have anything to add.
Yeah, I can add, but Sharif. Okay, basically, means what I know, Tesla had a statement which he has said during his time that I am only a discoverer in this whole nature. You may have heard that. So means he even doesn't thought himself of an inventor, rather a discoverer. So it just means that he was basically finding all the basic things that exist in this cosmos or this in this universe, rather than he thinking that I am going to make this and that. He's just finding out the laws of the cosmos and laws of the universe. So basically he was finding out how everything is architected, rather than, and uh, basically his contribution to wireless technologies was, means,
Sorry about that. I had to
useful.
phone
Yeah,
call
sure.
here.
Yeah.
Yeah, one of the interesting things when you look at invention, and often we talk about invention as being this great thing and coming up with ideas, and at any given day I might get several folks that contact me and say, I've got this great invention, can you introduce me to whichever billionaire that's out there? And the thing is I think Tesla showcases it's not invention that really advances you, it's implementation.
Finding everything.
Yeah, you find all the stuff, but you still have, if you want to make money on it or be successful with it, you still have to implement. You still have to bring it to market, and that's kind of was the difference between Marconi and Tesla.
Yeah, exactly, and Edison also, I guess.
Right. Tesla was focused on the technology, and Marconi was focused on commercializing it, and that's why Marconi was initially more successful.
Exactly. Yeah. Like if he had focused on generating revenues, then he must have been even a much more millionaire or something, like even more than Edison and Marconi. But he's just focused on making the technologies there, and just shifted to some remote place and just work on his thoughts and all.
Yeah. If you look at Elon Musk, who runs the Tesla company, he's not an inventor. He's a marketer, so he's able to monetize inventions, but he didn't invent any of it.
Exactly. Yeah.
But do you believe that the without better product development we can market a better service or products and it can be successful?
Yeah, if you've got the skills. The thing is often what happens is when somebody's coming to market, they don't know the skills they need, and so they don't acquire them. You need skills in manufacturing. You need skills, even if you're not manufacturing, you're outsourcing. You still need skills in manufacturing, so you know what to tell the manufacturer, and you know how to design products so they can be cheaply manufactured. And often when folks come up with an idea and try to bring it to market, the team they develop lacks the critical skills needed to implement the ideas, and so it fails. Coming up with the breadth of skills you need in building a team that not only can work together, but has the skills necessary to get the job done is critical. And recognizing there are all kinds of ways to get skills. You can get skills with consultants, but then again, you have to have some level of core knowledge so you know which consultants to hire. Because if you hire the wrong consultants, you're still not going to go anyplace. And so it's building up that core knowledge of how to get something done, or knowing how to work with people that have that core knowledge so that they will contribute to the overall effort. Sure, some of the better VCs in Silicon Valley, they don't just provide money, they provide skills. And that's why more of their companies are successful than the ones that just provide money. Because often with regard to a startup or a new company, it's the skills that are the problem. Well, a little bit on monetary control, but that's a skill. So in the end, the success of the Valley is really predicated on the fact that there is a critical mass of a broad set of skills that exist in Silicon Valley that can be pulled from And that allowed Silicon Valley to be an incubator for future companies far more aggressively than other places in the United States or the world. Um, Things are changing. Singapore, Korea, Japan, China, they all have critical mass of skills, and so they're able to produce in their own environments very similar to what Silicon Valley can do. But Silicon Valley did have a head start, and the other areas are at a somewhat of a disadvantage because they just simply don't have the history. But part of that history is negative. People don't like to break old rules, and often a newer environment, an emerging economy, doesn't know what they're not supposed to do, and so they'll often discover things that were possible that were naysayed by the folks that were more experienced. In fact, I think our history is often defined by people that have done things that were impossible. Electric cars, for instance, take Tesla. GM had the prior successful effort with electric cars, never was able to bring the thing to market. Huge money hole. Even though everybody that had one of their test electric cars loved them, GM couldn't bring them to market. Tesla didn't take that as a negative and did what General Motors couldn't do. A little itty bitty startup ended up being more valuable than one of the largest auto companies in the world. Well, actually, all the largest auto companies in the world at one time, because they did what the other companies thought was impossible. So often it is a newer company that often has to create the new technology. In fact, the history of the computer is that way. When the computer first came out in the 1940s and 50s, the majority of companies said the market didn't need them. And when we started talking about personal computers early on, the theory was might only need 3 or 4 of them in the world. There was no market for the damn things. And then they took over the world. And then when we had the smartphone came out, first folks were kind of convinced that it really wasn't a thing. IBM came out with the first smartphone. They were never a smartphone power. And then the smartphones that came out after that were all focused on business. And both Palm and Microsoft said that was the only place that the smartphones should be focused on business. Then Apple came out with a consumer-focused phone and wiped everybody out. So it sometimes it's the new entry to the market that doesn't realize they're not supposed to do or what they're doing is impossible, and they do it anyway. That makes the difference, and that's probably one of the biggest advantages of an emerging economy. They don't know what they can't do, and they're willing to try things that the more experienced people aren't willing to try because they believe that they're dead ends. They believe that you can't do it that way. They believe that the rules are inviolate, and the fact of the matter is there's almost no rule that's inviolate. We once believed you couldn't go faster than the speed of sound. In fact, we once believed if women went on a train at over 70 miles per hour, it would destroy their reproductive system. So that all untrue, obviously. So at least every time I go on a jet, I haven't seen any of those catastrophic events. So in the end, I think the one big advantage an emerging economy has is the fact that they don't know what's impossible yet, and invariably they've got that potential to do things that we think are impossible because they just don't believe that. So there's that status of belief you have to be aware of as well. And for God's sakes, if somebody tells you you can't do something, take that with a grain of salt.
Mm-hmm. Professor Rob, as Tesla have a lot of innovation, do you believe that now this kind of idea, like radio, like energy, like drones, automations, it's possible to market it and commercialize it?
Oh, there's great need for it. As I said, there's a broadcast energy as a huge need because we've got this massive sensor problem. We're going to be deploying millions of them and really no inexpensive way to power them. And if you look at automotives, cars, one of the big problems we've got with cars is they may have upwards of 5 networks in them, all incompatible with each other, which is just nuts. It adds to the cost of assembling the automobiles, it adds to the cost of maintaining the automobiles, and it adds to the cost of what it takes to repair an automobile once it's in an accident. If you could do broadcast power and you also have broadcast data, then you're just plugging and unplugging sensors. You don't have to run power to them, and it would make every aspect of the automobile far cheaper. And when we look at these new autonomous cars that are coming to market, they have huge sensor sets. I mean, that's how they're able to detect a kid that's behind a car, or detect a ball that's coming across, or detect something the driver can't see, particularly in night and climate weather, as they're using LED, LiDAR, they're using radar. In some cases, they're even using sonar. So the need for a way to both, and we've got the data side reasonably well cooked, but the need to find a way to power these things and and replace them quickly and easily as needed has never been greater. And so there are these opportunities, and we have alternative technologies coming through like PoE for wired environments where you might be concerned about security or interference, where you could use a PoE that's power over Ethernet solution to provide both data and power in a wired, more secure fashion to peripherals using DC as opposed to AC and low voltage. Far cheaper to pull PoE wiring, and you don't typically need an electrician to do it. So there are all kinds of things the industry is currently exploring, and we're not at a steady state in terms of what we're going to finally end up having, and it provides an opportunity for an emerging economy to both create the technology, use it themselves to showcase its viability, and then once successful, spread it to other markets and other parts of the world.
Thank you, Mr. Shobik.
Yeah, yeah. Yeah, so means there are a lot of technologies that we do require means at our means in our lifestyle, but they are not being provided commercially at this stage. Like we can say that the self-driven cars, 20 years back, that are not at all in the thinking of people. But slowly, means these technologies that can be made are being provided slowly to the common people also. So maybe after 10 to 15 more years, there will be some new technologies that also be in the commercial scale to people. But currently, means we require lots of things in terms of technology for our convenience, and we can be provided with that, I guess. But that are not being provided in like commercially. There are a lot of things like there can be restrictions or there can be some commercial battles for these things. Like, but maybe for one reason or the other, these are not provided commercially to the common people at this moment. I guess I believe. But we require this, and maybe after 10 to 15 years there will be some new technology, and 10 years after that there will be something new again. Like that, it keeps on moving on. And technology is some sort of a thing that will always make it progress in one direction. So there will be always new and new things to be provided. But means in terms of the wireless technologies, the base was provided in the early 1900s, as we can see, means in the time of Nikola Tesla when he was doing his early researches. The base of the wireless technologies was drawn at that time, and all these things like the internet or all other wireless technologies, as we can see around today, like there are anything means almost 50 to 60% things are based on wireless technologies. So all this means the base was started way back in 1900s in times of Nikola Tesla, and like it means there is a lot of instruments and lot of other inventions which was provided due to that, like the today's cell phones or the self-driven cars, all are due to all are as a result of those technologies that were being worked out by Nikola Tesla at that time. So then this trend will means keep on providing more new and new technologies, as I am saying, in the upcoming days, like after 10 years, there will be something even new, even modern to what there is today. So I believe this trend will go on like this. And
Thank you. Mr. Shobik, what's your concluding remarks for today's session?
concluding means, what basically I can say is that the base of all these technologies of the modern world are based on the work of Nikola Tesla and his inventions for the his discoveries in the early days of his career, like in the 1900s and 1920s and 1930s. And later on, all of the other things, all of the modern texts had been just just yeah, what we say, had been derived from those technologies only that Tesla has worked upon at that time. So he can be said as main the main person behind these technologies, all of this.
Mhm. Thank you, Professor Rob. What's your concluding remarks for today's sessions, and uh, what is your advice different startup those who are working with Tesla innovation?
So the lesson that Tesla teaches is that invention in and of itself isn't a great path. His life was not one that I think anybody would want to share. The real advantage is when you can take a technology, and Musk is a case in point, take a technology that somebody else invented and bring it to market. And if you can do both, then you've got a critical home run. But you don't. But the invention side of it isn't necessarily on the critical path as long as there are other inventors on the market. Discovering a technology and being able to monetize it is the critical path. The other thing I'd like to leave everybody with is that there's a category of ethics we didn't really talk about when it comes to bringing forth technology, and I'm bringing it up because it's topical. The big concern right now with artificial intelligence isn't that it's just moving too fast for us to embrace, is that the ethical controls don't exist to surround it, and so building something that is incredibly fast, can outthink humans, and can make decisions, but has no ethical constraints, could very well be very damaging to the human race. You do need to put guardrails on things, particularly things you don't yet understand. And I think nuclear energy is a case in point, and in that regard, because we clearly developed the destructive side of nuclear energy long before we developed the beneficial side, and we still aren't using the beneficial side to its full extent, and overusing the destructive side. So learning how to bring things to market, to monetize them, but doing so in an ethical way, so we don't recreate the problem the petrochemical market created, we don't recreate the problem that nuclear energy initially created, and so that we progress forward and don't wipe out the human race in the process is the way to look at all of these technologies, and make sure we not only think about the material side of it, but we think about the human impact side, and we don't create another crime against humanity.
Thank you. This is an excellent discussion, and we have Nikola Tesla Technology Conference. Those who want to publish paper, they can submit their paper to us, and this July, and definitely it's under Nikola Tesla Technologies different issues. So thank you, Mr. Shovik, and thank you, Professor Brown and Mr. David Smith, for your continuous support for World Talent Economy Forum. Thank you. Bye bye, and take care.
Thank you.